Okay, so ready to give those brains a workout.
I think we've got just the thing.
Today, we are diving deep into the world of area and perimeter.
And we've got these really cool excerpts from this educational text. It's all about teaching math, but not just, formulas and equations.
Yeah.
It uses all these visual, hands-on examples.
I love that. Like what?
Think stamps, footprints, even tiles.
Okay, and now I'm intrigued. So we're basically looking at how we measure space.
Ooh.
Right. But not just how long something is, but how much surface it covers.
Exactly. And what's so cool about this text is it really helps you understand the why behind the calculations. You're not just memorizing formulas, you're actually getting it.
Okay, I like where this is going. I did notice, like on page 34, they have this challenge.
Yeah.
Make as many different rectangles as you can using 12 squares.
Oh, yeah, that one.
And, full disclosure, I may have gotten a little carried away trying to find every single combination possible.
Yeah. Well, it's a great way to illustrate a really important point about area and perimeter, because no matter how you arrange those 12 squares, the area stays the same. It's always going to be 12 square units.
Right.
But the perimeter, that's the length around the shape.
Right.
That changes with every new rectangle you make.
So, like, if I made a really long, thin rectangle with those 12 squares, it would have a way bigger perimeter than, say, a nice, compact 3x4 rectangle, even though they use the same number of squares.
Exactly. And this isn't just some abstract geometry thing either. Think about a farmer trying to figure out how much fencing they need for their land.
Okay, I see.
Or a designer figuring out the footprint of a building. Understanding how perimeter changes depending on the shape is actually super useful in the real world.
That's a great point. So how does this text take that idea even further?
Well, they bring in some really clever visual aids. Like on pages 35 and 36, they use stamps as an example. They have you compare how much space different size stamps take up.
Oh, I like that.
It's such a good way to wrap your head around the concept of area.
It's true. Like when you see a giant commemorative stamp next to a tiny little postage stamp,
Yeah.
the difference in area is just so obvious. It's not just some formula in a textbook anymore.
Right. It helps you develop this gut feeling for area.
Yeah.
And that's so much more powerful than just memorizing something.
Now, I am curious about how they handle irregular shapes,
Yeah.
Like footprints on pages 36 to 39. You can't exactly measure those with a ruler,
Right.
or can you?
Well, yeah, it's not so easy, is it? You're right. Irregular shapes can be kind of tricky.
Yeah.
But this text, it actually breaks it down in a really smart way.
Okay, I'm listening.
It's all about using smaller units to approximate the area.
Okay, so like instead of trying to measure every single curve and bump perfectly,
Yeah, exactly.
you're kind of like finding the closest match you can get.
Exactly. They actually have you do this activity
Oh, really?
where you trace your hand on grid paper
Okay.
and a friend's hand
I see where you're going with this.
so you can compare.
Yeah.
And it's a fun way to really visualize.
That's a good point.
Yeah.
So you can see the difference in size. But how do you actually get a measurement from that, though?
Well, that's where the grid paper comes in. Because each square on the grid represents a certain unit of measurement.
Right.
So you're essentially counting the squares to figure out the area.
Ah, that's actually really clever.
Yeah.
So it's like solving a puzzle almost. You're piecing together those squares to get as close to the actual area as possible.
Exactly. And that skill, being able to approximate like that,
Yeah,
it comes in handy way more than you might think.
I bet. It reminds me of those online games where you have to like estimate the area of a shape,
Oh, yeah.
and the closer you are, the more points you get.
Exactly. And that's kind of the point here. It's
Yeah.
not about being perfect. It's more about, developing a good sense of proportion
Right,
and
yeah.
scale.
So we've done squares, rectangles, even those irregular, weird shapes. What's next?
Well, the text takes us even deeper into the geometric jungle, starting, let's see, page 40, with triangles.
Triangles. Okay, I'll admit those always seemed a bit more, I don't know, complicated to me.
Yeah, they can be, but they don't have to be.
Okay, good.
And this text does a really good job of breaking it down, making it clear.
Well, how so?
So they show you how you can often relate a triangle's area back to a rectangle.
Oh, right. Like a right triangle is always half of a rectangle.
Yeah.
With the same base and height.
Exactly. But it goes beyond just right triangles, too.
Really?
The text, they illustrate all these different ways you can divide up more complex shapes.
Like into triangles.
Yeah, like building blocks to figure out their areas.
Huh. That's really cool. I never thought about it like that. Using triangles as a tool to measure other shapes.
It's a pretty big deal in geometry. And it's not just theoretical either. This stuff has real world applications.
Oh, I bet.
Think surveying, architecture, even things like, computer graphics.
Oh, wow. I had no idea. Okay, my mind is officially blown.
Okay.
So we've gone from simple squares to, like, conquering complex shapes with the power of triangles.
Right.
What else does this text have in store for us?
Well, they introduce this really interesting puzzle. Let's see, at pages 44 to 46, it's called the 5-square puzzle.
Oh, yeah, I think I've seen that one. You had to take 5 squares, right? And
Yeah.
connect them edge to edge, and you try to make as many different shapes as possible.
Exactly. Sounds pretty basic, right?
Yeah.
But guess what? There are actually over 2,000 solutions to this puzzle.
Are you serious? 2,000 from just 5 squares.
Yeah. And it all comes down to this really cool area of math called combinatorics.
Combinatorics. Okay, you're going to have to break that one down for me.
Basically, it's all about figuring out how many different ways you can combine things or arrange things. And it's not just about puzzles either. Combinatorics is used everywhere.
Like where?
Oh, like designing computer algorithms, cracking codes, even understanding like the probability in games of chance.
Wow. I had no idea. This simple little puzzle was connected to all that.
Right.
It's like a gateway into this whole other world of math.
Exactly.
This is why I love doing these deep dives. So we've gone from puzzles to, wait, tiles.
Tile.
The text goes on to talk about tile making
Oh, yeah.
on pages 47 to 49. What's the connection there?
It's pretty cool, actually. They both kind of get at this idea of tessellations.
Tessellations.
Oh,
Okay,
yeah.
refresh my memory on that one.
Like how you can arrange shapes to cover a surface, but without any gaps or overlap.
Oh, right, like a mosaic or
Exactly.
a tile floor.
Exactly.
Okay, so the 5-square puzzle, that's like mini tessellations.
Right.
And then the tile making thing, that's next level.
Exactly. And they use this like simple activity to introduce some surprisingly complex ideas.
Like what?
Well, understanding tessellations, it can actually help you like design stronger building materials.
Yeah.
Yeah. It's even used in like computer animation to create those realistic looking textures and stuff.
Wow. I never would guessed that those amazing visuals in like animated movies were connected to something as simple as tile patterns.
Huh.
That's really cool.
It is pretty cool.
I guess it just goes to show math really is everywhere.
It really is.
You just got to know where to look.
Right.
So we covered a lot of ground here. We went from basic area and perimeter to like puzzles and tiles and even computer animation.
Yeah.
What's the main takeaway for our listeners today?
I think the big thing is like area and perimeter, they're not just these like abstract formulas.
Yeah.
They're actually tools that we can use to understand the world around us.
That's a great way to put it.
Whether you're designing a garden or wrapping a present or just, appreciating the patterns in nature.
I love that.
These concepts, they're everywhere.
They really are. So in a way, it's like this text has given us this whole new way of seeing things
Yeah.
just by understanding these simple math ideas.
It's pretty amazing.
And the best part is, it doesn't stop here. This is just the beginning, right? I mean, once you start noticing these things, area, perimeter, shapes.
Oh, yeah. You'll see them everywhere.
Exactly. You start to see them everywhere. This has been an awesome deep dive.
Yeah.
It really makes you think, what other everyday things could we use to explore these concepts?
Yeah.
What about like the shapes of shadows
Yeah.
or the intricate patterns on a leaf? So much to explore. Keep your eyes peeled and your minds open out there, folks, because like we've seen today, the world is full of math.